Unit tangent vector to a given vector valued function. The tangent vector is just the derivative vector, so that's easy enough to do. R prime. We still have some work because product rules and stuff involved, but we have a negative e to the minus t cosine t plus e to the minus t times the negative sine of t in the first component, 2t in the second component. For the third component, we would write 1 over 1 minus t as 1 minus t to the negative 1, and the derivative would be negative 1 minus t times the negative 1 from the chain rule, so that to the negative 2, sorry. So that would look like 1 over 1 minus t quantity squared. And that'll do it for the derivative. And the tangent, the unit tangent, is the derivative. So let's write this out again. Minus e to the minus t cosine t minus e to the minus t sine t, comma 2t, comma 1 over 1 minus t quantity squared, divided by the magnitude of this thing. So the magnitude of this thing is the square root of each component squared. So it gets a little messy here. We have minus e to the minus t cosine t plus e to the minus t sine t quantity squared plus 2t quantity squared plus 1 over 1 minus t squared quantity squared. And that's our unit tangent vector for any value of t. We are supposed to find it in particular for t equals 0. So the unit tangent at 0 is easier. E to the 0 is 1, cosine of 0 is 1, so we have a minus 1. Sine of 0 is 0, 2 times 0 is 0. Right here, 1 over 1 minus 0 quantity squared is 1. So the numerator is this vector, minus 1, 0, 1, and the denominator, we have a square root of, it looks like negative 1 quantity squared plus 0 squared plus 1 squared. So we have minus 1, 0, 1 all over the square root of 2. And that is our unit tangent vector at that particular point.